What's up, water cooler? I'm Tristan Linville. This is Michael Callahan. He's kind of okay sometimes. And this is episode 21
So
of
timely.
Water Cooler Talks on Manufacturing and Technology. What's up, Michael? How you doing?
Right now I'm just thinking of going to my counselor later because, I just got put down this morning. So, but it's okay, because
Yeah.
we're having some record counts in pollen. Spring is here, and my golf game's worse than it's ever been. So it's a good time.
Yeah.
It's a good
Love it.
time.
Well, do you want to hear an extra decent joke for an extra decent person? You.
It may make my day turn around. So that would be great.
All right. Well, here it is. It's really a shout out to the ladies out there. So, ladies, if
Wow.
your men can't appreciate a good fruit joke, you need to let that man go.
Lemon go, lemon.
No, mango, mango.
That was so good that it took some explaining. Yeah, it's that day. Woo!
That
Kristen, I
just
sure hope
means
we
it.
have someone better than we've been this morning coming to hang out.
We do. We have a fantastic guest,
I hope he
and
wants to speak for the next 25 minutes.
well, let's not waste any time, shall we?
Let's do it.
All right, so welcome to the stage, everyone. Let's bring him front and center.
Drum roll.
Josh Leath.
Woo!
How you guys doing today?
What's going on?
Josh. We've bad jokes. Michael can't talk, but Josh, everybody, works at Yaskawa Motoman, and he is the senior product manager for thermal applications. And so, Josh, you're way smarter than us. Can you just tell the people what that means?
Yeah, that's a whole lot
Sure.
of stuff right there.
Yeah. So with Yaskawa Motoman, we do robotics, right? So automation of all forms, across from drives and motor, even the fly cam that you see at the football games, whatnot. That's a Yaskawa driven product, for example. But here in our facility, we do the robotic arms. So anything that's a repeatable type process. Those blue arms, sometimes other colors that you see in factories, any of those blue arms are typically Yaskawa arms. So we go across quite a few different applications. My area is thermal, like you said. That basically means welding. So for MIG welding, TIG welding, laser welding, spot welding, even cutting with plasma torches, cutting with lasers, that kind of all falls under me. And then under me, I mean, I'm kind of the halfway point between the customers and sales team and then our engineering group. So anything that needs to be scoped as a standard product, I kind of help that, to make sure it kind of stays within bounds, hits the cost targets that it needs to do, functions that it needs to do. But yeah, it keeps things exciting.
Those are
I
important things.
mean, and it's funny because like that job is really any product manager, program managers, like that job is so hard because you have to be technical enough to really understand the workings in engineering.
Right.
And
Yep.
then you have to be like customer facing enough to kind of bridge that gap between the different business units. So it's I can only imagine the stuff that you deal with on a day to day. So
Hey,
thank you
Josh,
for
Yeah.
fighting the good fight.
would love
Yeah,
to get
absolutely. Yeah, it's fun.
someone's contact from the video camera piece so that when my team's about to win the national championship, we could just, like distract the other team a little bit, maybe. That'd be great.
Kind of intercept the football midair.
Yeah,
Yeah, that'd be
exactly.
fun. Block it.
I don't know
Yeah.
what happened, why it dropped and stopped the kick from going in, but we'll have to look at it.
We'll see what
I
we can
mean,
do.
speaking of college sports, I'm going to cue it up now. That may be the big question at the end, and I'm just going to throw it out there. So we'll get to that. And Josh, I don't even care if you don't really follow basketball. You're still going to have to make some picks.
That's all right. Yeah, I got a bracket out there. Doesn't look too good, but I
Love
got
it.
one.
I love it. I love it. So, anyways, to kind of jump into it, guys, we brought on Josh to really talk about automation and robotics, just in general, really, and then to share a little bit about what Yaskawa does as a business, because they do have a great product, and you're going to see them at every trade show, every manufacturing trade show, supply chain trade shows. They're all over the place. So, fantastic marketing department led there by my friend and Josh's friend Melissa. She's crushing it. But just kind of want to talk about we hear all the time, Michael and I do when we're out in the market talking to different manufacturers about all the fancy buzz, right? AI, automation, we don't have enough people, skilled labor shortages, that kind of thing. So let's just talk about automation from a macro scale and kind of simplify it and talk about the reasons why it's needed, and kind of what you see from being a direct vendor in that space.
Sure. Yeah, automation kind of dates back to the 70s. So our company started as a motor company. So what's a good way to sell six motors at a time? We'll put them in a robot arm, right? So you get nice repeatability with them. Obviously, better today than it was in the 70s. And a lot of automotive companies really started automating at that time through the 70s, 80s, even the 90s. So that's been the largest space that automation's been used in because you have the same thing, the same car, the same pillars, whatnot in the car, all being welded the same, painted the same over and over again. So you have that repeatability of a lot of products that need produced rather than stopping at different stations and doing things by hand. That robot never wears out. It can do that constantly. A lot of it's just because they need that economies of scale. You don't want to pay $100,000 for a basic car, right? You want that $20,000, $30,000 price point. So again, automotive has been the early adopter and continues to adopt it, but it's really gone into every different industry. So not just welding anymore, but more and more companies, these startup companies, looking at things like the food market. So if I'm at a Wendy's or McDonald's, there's people in the back doing that repetitive job. Is there a way for a robot to do that? Because those people, typically that average tenure in fast food is about 3 months. So it's something that they have constant turnover. It's not maybe a job they want to do. Can you put that person in a more value add role rather than having them do something that's boring that eventually they're going to quit? So not just food, but everywhere. Yeah, it's job figures for February. The ones for March actually come out tomorrow. So I got February here in front of me, but there's 7 million job seekers, but there's 7.7 million job openings. So more job openings than seekers. Those companies aren't going to have the productivity that they want without somebody in that space or some kind of technology to help them along the way.
That's amazing.
Yeah,
Yeah.
for sure.
We got
Um,
this
when
week, so I had some help with that.
Got a visitor back there.
I love it. See, this is a family show.
Family show. Rated, rated B.
Well, kind of, one of my big things when we're talking about like, and this was my own perception before kind of joining my current company and kind of seeing what's out there in different manufacturers of what they're doing, right? I came up in defense manufacturing, so machine shop and a lot of things, yes, were automated. But at the same time, I mean, talk welding applications, for example, we were always struggling to find really skilled welders. I mean, it's
Yeah.
it's kind of a profession that is so underappreciated, and you could argue culturally, the US has kind of offloaded that a little bit and taken shop out of the high schools and so forth. So when it comes to the welding applications specifically, and you mentioned the economies of scale, I mean, how are you guys transforming, and what's that process of where these companies decide, man, I need to go buy a robot to help me weld?
I want to add something to that I think may help because we get into this conversation when we talk about AI. We get in this
Mhm.
conversation really when we start bringing on any guest, and it's I have a problem. Where do I start? Like, help someone that's trying to figure out, am I at that point now that I need to go to automation robotics? What things do they need to think about? You mentioned repetitive earlier, but help them come to that conclusion of I should reach out to, Josh to talk through this.
Yeah, absolutely. Both great questions. So to kind of start with Tristan's there, the American Welding Society kind of hits it on the head with what you said as far as there's not enough skilled welders in the workplace. Every year they come out with their numbers as well, and it's always kind of hovering around 400,000 welder shortage within the next couple of years. So if there's not somebody there to weld, either you have to outsource that or bring in some kind of technology or promote as far as those skills with robotics, and this kind of gets into a little bit of Michael's question too, but When you train somebody on robotics, you don't want somebody that went to school for a degree for robotics. You want a welder. You want somebody that knows the skill, that knows the process. It's very easy to teach them how to train a robot because they're training the robot to kind of do that repetitive job that they were doing. Well, again, they can do something more value add like weld inspection, maybe some more intricate parts, maybe something that's a lower throughput rather than the high scale items that they're wanting to try to automate. But it's something that, again, the robot, there's no magic science there that it knows if it's a good weld or bad weld. It has to be that person teaching it how to do that welding. Same for painting. Same, we mentioned, cooking back kitchen stuff. Same for palletizing. Anything where a human has to use a little bit of ingenuity and what their trainings are to figure it out. You still need those skills in place in order to use the robotics to leverage that tool and technology. When people are starting to look at robots, though, it's really, where's your bottlenecks? What are the items where, that production flow really slows down because the process takes so long to do it by hand? Again, if you can take that process, speed it up, or add tools and technology to it, kind of the basic manufacturing 101, right? You have limited labor, limited resources. If you add technology to it, it excels everything there. So, what can we do to help to put a robot in place on any of those type of processes that they're going to help alleviate that bottleneck? Usually that's welding. So welding is a very easy one to say, hey, it's the same part, it's the same bead, same seam over and over again. Can't find enough welders. What do I do? Welding is that nice kind of gateway into automation. So it's very easy. It's been proven for many decades to get people, started with it. Once they get used to that, then we kind of help look at other processes. So is it painting? Is it sanding and grinding? Is it packaging? Is it even some assembly? Historically, though, a lot of that, because it's not repetitive and, trying to put one widget together with another widget, it's hard for a robot to sometimes figure that out. So more and more on the AI side, different sensor technology that we and other companies are using to help figure that out. NVIDIA has been a huge proponent of this, and they've really helped accelerate a lot of companies the last couple of years with their environment they've been coming up with that kind of does that processing for you to figure out, all right, if I'm putting gear together inside of another hole, instead of trying to feel that out like a human would or just visually say, oh, I need to turn it like this. That path program that goes on the back end is very complex from the robot side. So how can it do it in the most successful way with those models that NVIDIA and some of these other AI companies are running to do that? But it's very difficult too if you just throw a lot of random stuff at it, right? So in the grocery space, Kroger's and all these stores want to try to automate some of these distribution centers. Banana looks very different from an apple, which looks very different than a rack of ribs, right? So if I'm trying to pick up and handle all these different things, how do I do so with a gripper that might look like a human hand? But again, lots of moving parts even in your human hand. So the computer back end, the AI side is trying to figure out how do I manipulate that gripper in order to pick up those pieces, and then am I picking up the right one? Is that really an apple, or is that a pear that looks like an apple? So there's a lot of complexities there that, again, in the past you just haven't been able to automate that we're getting closer to today with a lot of those AI type technologies.
That's interesting. That's really interesting. It's exciting to think about. I mean, as you're talking about Kroger, and you do this pickup or whatever you want to call it, where they have a team that literally goes through and picks these things. It's like, I'm thinking that we're not far off from a world where a robot's probably getting close to being able to do some of that stuff for them, and it's all same task every time, different products. So that's interesting.
Yep. Yeah, and a lot of that, if you look at the Kroger's doing that pick list type application, a lot of it's high school kids, people just starting the workforce, temporary jobs. That number has decreased. So the amount of high schoolers 20 years ago that were willing to participate even part-time in the workforce has gone from 50, 60% down to 15 to 20% more recently. And, that's everything. It's sports, it's scholarship programs that they're trying to get a part of that, the job maybe isn't valuable to them now. They don't need that minimum wage. They'd rather put that towards some other effort. Lots of activities, right? That we all have resources for now too, in that age group. So that cheap labor kind of goes away. What do? You have to find other solution and automation and whatnot. Cool one with Kroger though, at least around here they have that Kroger Boost delivery. So they drop it
Mhm.
off at your front door, right? Driver comes out, drops off the stuff. all that from those distribution centers are based on automation. So, in the past, I've done click list and I wanted this frozen vegetable and I got something completely different. Those errors don't happen when it's an automated
Yeah.
factory. So those errors go away. It costs Kroger less on that waste and refunds that they have to go, back and say, "Oh, sorry, brought you the wrong thing. Here's the right one. Refund the old one." Blah blah blah. So it's a great way to kind of eliminate those errors and make a happier, consumer in that regard too.
Would you say, and I'm asking this question with a thought that you may not have any specifics, but would you say there's a general high level percentage increase in accuracy when they move from manual labor to something like automation? Like, is there a general number that you all typically see?
It's hard to tie a number to it when it's, a variety of different applications. But if you go from things like welding, where I have 16 different people doing the same weld, the guy that's been there for 20 years, who's a skilled welder that has the certifications, he's probably going to do a better job than the kid that just started.
Mhm.
And there's also that joke other people have used, the robots don't, come in tired. They got, they don't need a good night's sleep. They don't come up in hungover. They don't have to pass a drug test. Some of those are unfortunate comparisons. But it's the fact as far as, if I'm going to do an accurate weld, and sometimes if it's automobile, people's lives are counting on this. It has to be a good quality weld. So even from the robot side, after it does the weld, there's other technology that can come in and scan that weld to make sure, yes, that weld is in place. It's done accurately rather than somebody that's trying to hit a number every hour and move on to the next thing. So even from the safety aspect, that's, a big part of why automotive has pushed this so much. But even heavy equipment. So some of our biggest growth last few years has really come from agricultural and construction equipment manufacturers, where it's big, heavy, I-beams and whatnot being put in place, as well as, pieces that can't fail under pressure. So how do you
Mhm.
make sure that's done right? Again, with that repetitive automation, that's one way to do that. But it does take, as far as the design engineering and everything, kind of put forth to make sure that those things are safe. So the robots, again, as a technology tool, are a good way to kind of certify that that's done right. Good example on that too. A few years ago, I believe it was Honda, and I think Toyota had a similar issue. It's in the news, nothing secret here. They found out that, when a car was in service, that it had missed some welds on some very, safety critical type components. So rather than recalling, I believe it was on an SUV, instead of recalling, hundreds of thousands of SUVs to come in and inspect and make sure that that weld's there, they could go back to the data. They found out that somebody had changed a weld program. They could find out exactly what day and time that happened, and then serialize, because they have full traceability on those vehicles, to know, oh, we only have to, bring back 10 or 12 that missed that weld, rather than, millions and millions of dollars of expense there. So
Holy
really
smokes.
helps prevent issues, and then mitigate, when you do have an issue, what that looks like, how you're going to fix it.
That's crazy. That's amazing.
That is amazing. I mean, so I've got two things from that talk track. One is kind of back to those common barriers to entry, right? I mean, with Michael and I selling enterprise technology solutions, we have our barriers of entry, right? Somebody
Right.
had a bad experience in the last project they did, or they may look at price instead of value behind it. So, what are your kind of common barriers to entry as you guys and your sales team is out there in the market?
The biggest one is just people who feel that the robotics are too expensive, too complex. So,
Okay.
it's very intimidating when you go to these shows and you see some of these cells with lots of moving parts and positioners and robots and scanners and sensors and everything going off. Yeah, as a commoner, you look at that and think, there's no way I'd be able to comprehend what all is going on there. But that's where, we're a self-integrating company. We also work with a large number of integrators. That's where that expertise comes in. So folks that can say, I can see your process. I can do that also with a robot. And then here's the tools I'm going to have to need to integrate to do that. So it's that approachability and that kind of first step into it. We do have a lot, even as customers come in, they see the equipment, they're wowed by it. We prove it out on a robot in space. They get warmer to it, but still, though, what's this going to look like on my factory floor? Do I need somebody specially trained for this? And we help them through that. We provide training to their team. Usually, we really encourage having kind of a robot champion in place that's going to make sure that this is successful. Because a lot of companies, once you get the robot in, they realize, oh, we did that entire week's worth of production in a day and a half. Well, what am I going to do the rest of the week with this thing as it's collecting dust? You don't want that, right? It's just like somebody gets their job done, they sit for 3 days. Put them to work, right? Find other things to automate with it. And so it's
Yeah.
the how do I adopt different tooling, changeovers, whatnot for those robotics. A big one, though, recently, last few years, cobots, collaborative robots, really hit the scene. Much more approachable because you go to these trade shows. We have our version of this where you can grab that end of arm and move it around with your hand. You don't have to understand the whole XYZ right hand rule. Where am I at in space to manipulate these robots? It's so simple, even on the pendants that we've created with relative commands. So instead of X, Y, or X plus, Y plus, where am I with that direction with the robot with Cartesian coordinates? It's as simple as left, right, up, down relative to where you're holding that pendant. So if I move to one side of the robot or the other, that relative command follows me on that pendant. So simple. I had a video of my son when he was 6 years old, showed it to him once, and then handed it to him, and he drove the robot over, picked up I think it's a hand sanitizer we were doing a giveaway on, picked that up, moved over to the other block in a matter of, a minute and a half, right? So if a 6-year-old can pick that up that easy, anybody can comprehend as far as that, programming finesse that is required there.
That's awesome.
So to draw that parallel for my second point, you just added to it, right? Two big things you just kind of talked about was kind of the user experience, right? And I mean, if your 6-year-old son can do it, you can imagine that these applications can absolutely be utilized by grown professionals in, to accomplish complex tasks with, this ease of technology.
Right.
The other one you had mentioned was kind of the missing weld and going back through the traceability hierarchy and stuff like that. The same thing goes for enterprise technology and ERP, right? The modern systems today have those traceability hierarchies, those as built, those as maintained, so that you can go back and have that, right? And all of that comes with that modernization, whether it's robots and automation there, or whether it's your enterprise technology that is able to capture that data smartly, intelligently, so that you can go back and reference it later. So
Right. Yeah.
super cool things there.
I would raise my hand to a comment you made earlier about one of the biggest obstacles is people seeing it and think, wow, that's really complex. And I'm curious because I've always wondered this, like, what are typical integrations that happen? I mean, we have ERPs that are basically saying we need to build this production order. Like, how far do you see the integrations going? What does that look like, maybe from a high level? Because I'm guilty of that thought, and I think it would be very interesting to know, like, architecture or just high level common integrations that you see.
Sure. Yeah. And kind of a nice comparison to that too. Internally, my primary product base, we call it our standard product, which is just that, right? It's kind of a cookie cutter. It's a catalog product. We have a configurator. Any sales guy can go through and click the options that he wants, and it kind of spits out that quote for him to say, this is what it is. This is how long it's going to take to build. Very simple. So if he visits a customer today, he can give them a quote on the spot. Anywhere from 12 to 18 weeks, just depending on how many robots and other equipment needed, that customer will have delivered then after purchase order, invoice, all that, we'll have delivered that working system. So a lot of the lead time is just in-house, as we have to build these pieces together, and that production planning like any manufacturer goes through, but something that simple. On the other end of that spectrum, though, we do have our advanced systems groups as well as the integrators that we work with that might have to engineer something from the ground up. So here's a customer that it's not just a weld they're doing and that's moving on to the next line. Maybe they want to weld it, do some kind of assembly, some more welds. Also, there's a grinding maybe thing that has to happen after that weld, and then it gets palletized. So there's more complexity to that. So the engineers kind of behind that know, all right, here's the standard products we can use to kind of solve these issues. I don't have to re-engineer that, but maybe I have to engineer a solution or a new gripper, a new workpiece, whatnot, for the rest of those pieces to come into play. That can take longer, but it can be anywhere from that, 12 to 20 week window. Longest ones usually up to 40, 50 weeks for an extreme example. But those are a lot of moving parts and a much more complex system. But yeah, it's one of those. There is still a lot of expertise on the back end for those to get designed. Just like starting, to design a car, you can pick up a unit that's already designed and modify a few things, or start from the ground up, to build something completely unique.
That's cool.
Yeah.
Awesome.
So I think to kind of start heading us downhill to the finish line here, when it comes to kind of what's next in your guys' space, I know that you guys are always innovating. I know different markets geographically are better adopters, early adopters versus different geographic markets. I mean, what's kind of the next trends in the robotic space that you guys are foreseeing looking forward?
Yeah, we kind of hit on it earlier a little bit with the AI side. So we've also come up with our own controller. It's called the YNX series, or Motoman Next. That's using a lot of different sensor information. It's doing that processing on the back end. Some cool applications that we've seen for it are specifically in that assembly or inspection space. But we even had a demo in Japan where it was taking kind of used lunch trays with all the empty bowls and food and napkins and maybe some food waste and cups, and it was able to pick out, all right, here's my paper products, throw those away, here's my food products, throw those away, bowls go into this line, spoons and forks, whatnot, go into that line. So something that, again, very lame job for somebody to have to do all day, but if a robot can do it, put that person to work in the kitchen, designing new recipes, whatnot, right? So, or even, I've used, for example, in the food space, the Chick-fil-A approach. Put more people up front with smiling faces asking, how was everything? Is there anything else we can help you out with?
Mhm.
That's a value add. That's what consumers want. They don't care about what's in the back room, in that regard.
That's awesome. I have a question kind of along these lines, but if there was one myth around moving to automation or robotics, what would you say the one myth I want people to know is not true is this?
Oh yeah, absolutely. You hear it every day. It's robots are going to take a job. I have never been to a customer that's adopted robotics where, it might have replaced what that person was doing repetitively. And that person was probably somebody that, wasn't going to be in that role because it's boring. But they put them much more in a higher value added role. So it's something that, robots don't take jobs. It's a tool, it's technology to make sure that manufacturers are competitive. There's some statistics from the A3 Business Forum this year that says, through 2050, the U.S. will remain the strongest economy on the planet. So there's kind of that misnomer that China's more powerful than us because they have more production. Well, the last 10 years we've been doing a lot of reshoring with our products. There's a lot of talk with tariffs and whatnot too, which will affect that as well. But if manufacturers in the States want to be competitive, they have to adopt automation. I can tell you, China and all these other countries are also adopting it at record paces. But even between who our trading partners are, Europe is the largest trading partner as of this year. It's no longer China. So we're selling and buying more goods with Europe than what we're purchasing from China, for example. So it's a completely different, I think, mentality than it was 20 years ago with where things are produced, how they're produced. A lot of that's coming back home, but it's because of technology and things like robotics and automation. So if the company grows, you're going to hire more. You're not getting rid of anybody. It's again kind of a complete spin on that misnomer.
That's cool. I
Yeah.
like
So you mentioned A3. I know
Mhm.
Automate 2025 is coming up. Do you
Yep.
want to speak to kind of what you guys are doing there? And I know that's probably the next big show for you guys. Is that correct?
Yeah, we participate in a lot of shows, PEC
Yeah.
Expo, Modex, FabTech, IMTS was last year. It'll come back next year. Automate this year was kind of a weird year where it's in Detroit, so you won't see our booth on the floor at Automate this year. We will be in Chicago next year, and I think it's moving out west after that. We will be there for those shows. We're doing a little reception event at Automate. If you're interested, you're prospective customer or whatnot, reach out to me. We can see what we can do to get you invited to that. But it'll be a good show to see a lot of those technologies. You will see a lot of our robots there in technology partner booths. So a lot of those camera sensors, AI sensors, gripper companies, logistics companies, parcel. You'll see a lot of that there with our robots supporting it. So you'll see us walking around for that as well. But yeah, any of those shows coming up, the big show for me every year is Fab Tech. That's a really fun one because it's a lot of welding, a lot of cutting, all metal materials, but even that's changing a lot with new alloys and use of composites in some of that space. So something that again, look us up on our motoman.com webpage. It lists out all the events that you can see there.
Yeah, no, that's awesome. And I'll be at both of them, so I can't wait. So the big question of the day, and by the time this episode airs, you're either going to look like a genius or not, because we'll know who won the national championship. So when we look at game 1 of the Final Four, we've got Florida and Auburn, both 1 seeds, all 1 seeds here. Who do you got, Florida and Auburn?
Well, I can tell you I had Iowa State on one of those games, so I'm already busted there. But Florida Auburn,
Okay.
I still like Florida better in that space.
Okay. I can't stay in Florida because I went to Florida State, but and I got a buddy that works for the Auburn staff, so I'm going against you. I'm going Auburn
All
on
right.
that game.
Sounds
Game
good.
2, Houston Duke. Who do you got?
Houston all day. They've had an insane run the end of the season, and they've looked just solid. Incredible defense, incredible offense. So, not to any spoilers there, but that's my favorite to win it all.
All right, so Houston is the winner over Florida. We'll find out next Wednesday if Josh was right or wrong.
Who's your winner? Basketball guy right here.
I think I've got Auburn. I honestly think it's Auburn.
Yeah.
I think it's gonna be Auburn versus Duke. I'm going against both. I think Cooper Flag will bring Duke through, and I just can't pick Duke, so it's got to be Auburn.
We can do a little friendly beverage waiver, or
there you go.
on that coming up. So
that's it. So, all right, guys. Well, Josh, thanks for coming on. To the listeners, to the viewers, as always, drink your H2O. This is who's going to win it all in the NBA, and hope you enjoyed the show.
Absolutely. Thanks, guys, for having me on. It's been a lot of fun, and look forward to seeing you guys in the future.
All right, buddy. Thanks.
Thanks.